Algebra. Algebra is the part of mathematics in which letters and other general symbols are used to represent numbers and quantities in formulae and equations. What is the missing number in the above equation? The answer is 6, right? Because 6 minus 2 equals 4. Well, in algebra we don't use blank boxes, we use a letter. Usually an X or Y, but any letter is fine. So we write, X minus 2 equals 4. It is really that simple. The letter, in this case an X, just means we don't know this yet, and is often called the unknown or the variable. Why we use a letter? It is easier to write X than drawing boxes, and easier to say X than the empty box. Multiplication in algebra. What is the missing number? The answer is 2, right? Because 2 multiplied by 4 is equal to 8. Operations mean things like addition, subtraction, division, squaring, etc. If it isn't a number, it is probably an operation. But, when you see something like what is shown below, what part should you calculate first? Start at the left and go to the right? Or go from right to left? So, long ago people agreed to follow rules when doing calculations, and they are: plus is the positive sign, minus is the negative sign. When a number has no sign, it usually means that it is positive. Example, 5 is basically plus 5. And we can put around the numbers to avoid confusion. Example, 3x minus 2 can be written as 3x minus 2.
Hi, this is Rob. Welcome to Math Antics. In this lesson, we're going to learn some really important things about a whole branch of math called algebra. The first thing you need to know is that algebra is a lot like arithmetic. It follows all the rules of arithmetic, and it uses the same 4 main operations that arithmetic is built on: addition, subtraction, multiplication, and division. But algebra introduces a new element, the element of the unknown. When you were learning arithmetic, the only thing that was ever unknown was the answer to the problem. For example, you might have the problem 1 plus 2 equals what? The answer isn't known until you go ahead and do the arithmetic. Now, the important thing about algebra is that when we don't know what a number is yet, we use a symbol in its place. That symbol is usually just any letter of the alphabet. A really popular letter to choose is the letter X. So in arithmetic, we would just leave the problem like this: 1 plus 2 equals blank. And we would write in the answer when we did the addition. But in algebra, we'd write it like this: 1 plus 2 equals x. The x is a placeholder that stands for the number that we don't know yet. What we have here is a very basic algebraic equation. An equation is just a mathematical statement that 2 things are equal. An equation says the things on this side of the equal sign have the same value as the things on the other side of the equal sign. In this case, our equation's telling us that the known values on this side, 1 plus 2, are equal to what's on the other side, which happens to be the unknown value that we're calling x. One of the main goals in algebra is to figure out what the unknown values in equations are. And when you do that, it's called solving the equations. In this equation, it's pretty easy to see that the unknown value is just 3. All you have to do is actually add the 1 and 2 together on this side of the equation, and it turns into 3 equals x, which is the same as x equals 3. So now we know what x is. It's just 3. That almost seems too easy, doesn't it? And that's why in algebra, you're usually given an equation in a more complicated form, like this: x minus 2 equals 1. this is exactly the same equation as 1 plus 2 equals x, but it's been rearranged so that it's not quite as easy to tell what x is. So in algebra, solving equations is a lot like a game where you're given mixed up, complicated equations, and it's your job to simplify them and rearrange them until they're nice simple equations, like x equals 3, where it's easy to tell what the unknown values are. We're going to learn a lot more about how to actually do that, how to solve equations, in the next several videos. But for now, let's learn some important rules about how symbols can and can't be used in algebraic equations. The first rule you need to know is that the same symbol or letter can be used in different algebra problems to stand for different unknown values. For example, in the problem we just solved, the letter x was used to stand for the number 3, right? But x could stand for a different number in a different problem. Like if someone asks us to solve the equation 5 plus x equals 10. In order for the two sides of this equation to be equal, x must have the value 5 in this problem, because 5 plus 5 equals 10. So x, or any other symbol, can stand for different values in different problems. That's okay. But what's not okay is for a symbol to stand for different values in the same problem at the same time. For example, what if you had the equation x plus x equals 10? This equation says that if we add x to x, we'll get 10. And there's a lot of different numbers that we could add together to get 10, like 6 and 4. But if we had the first x stand for 6 and the second x stand for 4, then x would stand for two different values at the same time, and things could get really confusing. If you wanted symbols to stand for two different numbers at the same time, you'd need to use two different symbols, like x and y. So in algebra, whenever you see the same symbol repeated more than once in an equation, it's representing the same unknown value. Like if you see a really complicated algebraic equation like this, where x is repeated a lot of different times, all those x's stand for the same value, and it'll be your job to figure out what that value is. Okay, so for any particular equation, we can't use the same letter to represent two different numbers at the same time. But what about the other way around? Could we use two different letters to represent the same number? Yes, and here's an example of that. Let's say you have the equation a plus b equals 2. What could a and b stand for so that the equation's true? Well, if a was 0 and b was 2, then the equation would be true. Or we could switch them around. If a was 2 and b was 0, the equation would also be true. But there's another possibility. If a was 1 and b was also 1, that would make the equation true, right? So even though a and b are different symbols and would usually be used to represent different numbers, there are times when they might happen to represent the same number. Oh, and this problem can help us understand something very important about how symbols are used in algebra. Did you notice that there were different possible solutions for this equation? In other words, b could have the value 0, 1, or 2 depending on what the value of a was. If a is 0, then b must be 2. If a is 1, then b must be 1. And if a is 2, then b must be 0. B can't have two different values at the same time, but its value can change over time if the value of a changes. In algebra, b is what's called a variable because its value can vary or change. In fact, in this equation, both a and b are variables because their values will change depending on the value of each other. Actually, it's really common in algebra to refer to any letter as a variable, since letters can stand for different values in different problems. But at Mathematics, we'll usually just use the word variable when we're talking about values that can change or vary in the same problem. All right, so far we've learned that algebra is a lot like arithmetic, but that it includes unknown values and variables that we can solve for in equations. There's one other really important thing that I want to teach you that will help you understand what's going on in a lot of algebra problems, and it has to do with multiplication. Here are the four basic arithmetic operations: addition, subtraction, multiplication, and division. Although in algebra, you'll usually see division written in fraction form, like this. In arithmetic, all four operations have the same status, but in algebra, multiplication gets some special treatment. In algebra, multiplication is the default operation. That means if no other arithmetic operation is shown between two symbols, then you can just assume that they're being multiplied. The multiplication is implied. For example, instead of writing A times B, you can leave out the time symbol and just write AB. Since no operation is shown between these two symbols, you know that you're supposed to multiply A and B. Of course, you can't actually multiply A and B until you figure out what numbers they stand for. The advantage of this rule about multiplication is that it makes many algebraic equations less cluttered and easier to write down. For example, instead of this, A times B plus C times D equals 10, you could just write AB plus CD equals 10. You can also use this shorthand when you're multiplying a variable and a known number, like 2x, which means the same thing as 2 times x, or 3y, which means the same thing as 3 times y. Since the symbol and the number are right next to each other, the multiplication is implied. You don't have to write it down. Finally, some good news. Now I never have to write down that pesky multiplication symbol again. Oh yeah. Not so fast. There are some cases in algebra where you still need to use a multiplication symbol. For example, what if you want to show 2 times 5? If you just get rid of the time symbol and put the 2 right next to the 5, it's going to look like the 2-digit number 25, which is not the same as 2 times 5. So, whenever you need to show multiplication between two known numbers, you still have to use the time symbol, unless you use parentheses instead. But aren't parentheses used to show grouping in math? How can you use that to show multiplication? That's a good question. Parentheses are used to group things, but whenever you put two groups right next to each other with no operation between them, guess what operation's implied? Yep, multiplication. For example, if you see this, it means that the group A plus B is being multiplied by the group X plus Y. We could put a time symbol between the groups, but we don't have to because it's the default operation in algebra. The multiplication is just implied. So, going back to our problem, 2 times 5, if you wanted to, you could just put each of the numbers inside parentheses like this, and then you could get rid of the multiplication sign. Now this can't be confused with the number 25. And since the groups are right next to each other, you know that you need to multiply them. Of course, it might seem strange to have just one thing inside group symbols like this, but it's okay to do that in math. An alternate way that you could do this same thing would be to put just one of the numbers in parentheses, like this. Again, you won't confuse this with a 2-digit number, and you know that multiplication is implied. Okay, so we've learned that algebra is a lot like arithmetic, but it involves unknown values or variables that we need to solve for. And we learned that in algebra, the multiplication sign is usually not shown because it's the default operation. You can just assume that two things right next to each other are being multiplied. But why do we even care about algebra? Is it good for anything in the real world? Or is it just a bunch of tricky problems that keep students busy in school? Actually, algebra is very useful for describing or modeling things in the real world. It's a little hard to see that when you're just looking at all these numbers and symbols on the page of a math book. But it's a lot easier to see when you start taking algebraic equations and graphing their solutions. Graphing an equation is like using its different solutions to draw simple lines and curves that can be used to describe and predict things in real life. For example, there's a whole class of equations in algebra called linear equations because they form straight lines when you graph them. Those sorts of equations could help you describe the slope of a roof, or tell you how long it will take to get somewhere. Another class of algebraic equations, called quadratic equations, can be used to design telescope lenses, or describe how a ball flies through the air, or predict the growth of a population. So algebra is used all the time in fields like science, engineering, economics, and computer programming. And even though you might not need algebra to get by in your day-to-day life.
So divide both sides by 3. That means x equals 42. So in 3, 2, 1. Yes! All right, now to see how much butter I need.
It's still a very useful part of math. Thanks for watching Math Antics, and I'll see you next time. Learn more at mathantics.com.
Anything in the brackets is always done first. Then second comes the orders or powers as shown on the screen. Multiplication and division comes before addition and subtraction. First you have to deal with the brackets, powers, roots or orders before multiply, divide, add or subtract. For example 6x, 5 plus 3, is. We first deal with the brackets. We cannot simply multiply 6 with 5. Multiply or divide before you add or subtract. 2 plus 5 by 3 equals. You multiply first. The answer will be considered wrong if you add before you multiply.
Hello! Welcome to Teach Me Maths. My name is Jonathan Hicks and today we're doing BODMAS! Or is it BIDMAS? BODMAS, BIDMAS, well, it's more or less the same kind of thing. Let me start with an example to show you what it is. It's much easier to explain this topic with an example and then you should get the hang of it. So imagine I asked you to work out 2 plus 3 times 4. Seems fairly simple. 2 plus 3 is 5. Times that by 4 you get 20. Or do you? Because 3 times 4 is 12. And add that to 2, 12 plus 2 would give you 14. So maybe the answer is 14. Is it 20? Or is it 14? Now this is a bit of an issue, as hopefully you can see. I ask my classes when I teach maths every year to work out what this is just in their head and then sort of call out the answers, and about half the class tend to go for 20 and the other half of the class tend to go for 14. Now there's no great reason to say that one thing is better than the other. You know, you can see the maths is correct in both cases. 2 plus 3 is 5 and if you times that by 4 you do get 20. But we can't have such a simple sum like this and have half the people getting one answer and half the people getting a different answer all the time. We need to agree on one way of doing this. Doesn't really matter which way we go for, as long as we all do it the same way. Again, it's a bit like driving your car on the road. It doesn't really matter if you drive on the left-hand side or the right-hand side, as long as everyone drives on the same side, otherwise you'll have an accident. And BODMAS or BIDMAS is the order that you should work these things out in. So each of the letters in the word stand for something. It's an acronym, so I'll write it up here perhaps. So I prefer BODMAS personally, that's what I'll go with, but I'll explain the BIDMAS thing as well. So BODMAS. So B, many of you will be familiar with this already. B stands for brackets. So this, as I say, is in the order you need to work it out. So you always have to work out brackets first. O stands for other. Now if you're doing BIDMAS, you have an I here instead of an O. And the I would stand for indices or powers. The other actually includes all kinds of other things as well. It's not just indices that you can get here. You can get exponentials, trig functions, logs. There are a whole raft of different things that you might have to work out here. So it includes indices, but that's why I prefer BODMAS rather than BIDMAS, because strictly speaking it is other. It's anything other than everything else that appears in the list here. So the rest of these most people can guess fairly easily. D stands for division. M is obviously multiplication. And then finally you finish with addition and subtraction. So that's BODMAS. Those are what they stand for. And as I say, this tells you the order in which you should work these things out. So you should do brackets first. I wouldn't worry too much about the other things for now, but then you do division and multiplication, addition and subtraction. Now I say you do it in that order. Strictly speaking, that's not true. Division and multiplication come together as a pair. So I'm just going to put a box around those two. You don't necessarily do division before multiplication. You do all your division and multiplication before any of this stuff, but you do them together and you just work left to right. Addition and subtraction then also come together as a pair. So you don't necessarily do your addition before your subtraction. You do all your addition and subtraction together, working left to right. I'll give you some examples of this in a minute. So if we go back to our initial problem here, what order should we do these things in? Well, we should do brackets first. We don't have any brackets, so we don't need to worry about that. Then anything else, which we also don't need to worry about. But then we come on to division and multiplication. Now we need to do all the division and multiplication. No addition or subtraction, just division and multiplication. And we've only got one multiplication thing here, so you should work the 3 times the 4 out first. So that will give you 12. And then finally, you do any addition or subtraction. So the 12 then gets added to the 2. So the correct answer, if you like, is actually 14, not 20. As I say, there's no real reason for saying that this is wrong, it's just that we all need to agree. And this is the order that everybody's agreed on, so we have to do the same thing. So you should not write 20 for that one, you should put 14. 2 plus 3 times 4 is 14, because 3 4s are 12, and 2 plus 12 gives you 14. Alright, I'll do a few more examples so you sort of see how it works. But as long as you follow the order, it's really very easy. The maths in this case, the adding, subtracting, multiplying, dividing, tend to be very simple when they ask you these kinds of questions. So let's have 10 minus 6 divided by 2 plus 5. So, brackets, we don't have any brackets. Other, there's nothing else, we've just got division, addition and subtraction. So we've got to do the division first. So the 6 divided by 2 we've got to work out first. And the way I recommend you lay these out is you write out the whole thing again, replacing the bit that you're going to work out with what the answer is. So in this case, the 6 divided by 2 is going to become a 3. So you replace the 6 divided by 2 with a 3. The other bits on either side you don't change. So it's going to be 10 minus 6 divided by 2 plus 5. Then we come on to the next things. So addition and subtraction. And as I say, you don't do the addition before the subtraction. It's not 3 plus 5. You do addition and subtraction together. They come as a pair and you work left to right. So it's 10 minus 3, which gives you 7. Then add the 5 to it, which gives you 12. So 10 minus 6 divided by 2 plus 5 gives you 12. All right, let's try another one. We'll have some brackets this time. So 4 times 3 plus 7 divided by 2. So we'll work out the brackets first of all. So it doesn't matter what kind of thing is in the brackets. If you've got brackets, you've got to do the inside bit first. Multiplication and division would come before addition normally, but the brackets means you must do this bit first. So 3 plus 7 is going to become 10, and the other things aren't going to change. I'm going to leave those exactly as they are. So it's 4 times 3 plus 7, which is 10, divided by 2. Now I can do division and multiplication, and I do them together, working left to right. Again, don't do the division before the multiplication. Work left to right. So 4 times 10 will give me 40, divided by 2 gives me 20. So my final answer in this case is 20. Alright, so let's try a slightly harder one. Let's have 6 minus 4 times 3 plus 8 divided by 8. So we've got all of your operations in there. So brackets first, 6 minus 4 is 2. And as tempting as it might be, don't work out anything else on this line yet. Just do the one step at a time, so brackets first. The rest of it, the times by 3 plus the 8 divided by the other 8, just leave all that alone. All you've done is work out the brackets. Now, you can do division and multiplication. There's no other things in here. So we're going to do division and multiplication. We're going to do them together, working left to right. The only thing we're not going to do is the addition. So 2 times 3 becomes 6. We're not going to do the addition, leave that alone. And the 8 divided by 8, well, anything divided by itself is 1. So 8 divided by 8 is 1. Now we come on to the final step. You've got addition and subtraction. We've only got addition in this case, so you just work it out. 6 plus 1 gives you 7. So that complicated mess up there just works out to be 7. Right, one final example then, involving some other things. At this stage, all you really need to worry about is powers. Nothing else is ever going to appear in this, but it's very straightforward to do. So if you've got 3 times 4 plus 2 squared, the key thing is you've got to work out the powers, the indices, the other things, before you work out the multiplication or addition. So the 2 squared you've got to work out before anything else. So it's going to be 3 times 4 plus 4, because 2 squared, 2 times 2, gives you 4. Then you do multiplication, that's going to happen before addition. 3 times 4 is 12. Don't mess with the plus 4, leave that alone. And finally 12 plus 4 gives you 16. So powers, it's usually fairly obvious with powers. You can see they're kind of right in there. Don't mess with the powers, just do those first. Don't mix them with anything else, and then follow the rest of the operations. The key thing to remember with BODMAS is, apart from the fact that that's the order, division and multiplication must come together as a pair. You work left to right. The same with addition and subtraction. You don't necessarily do the addition before the subtraction. They come together as a pair and you work left to right.
Factoring is the process of finding the factors and splitting algebraic expressions accordingly. For example, factor 2y plus 6. Both 2y and 6 have a common factor of 2. 2y is 2 multiplied by y. 6 is 2 times 3. We can factor the whole expression into 2y plus 6 equals 2y plus 3. So 2y plus 6 has been factored into 2 and y plus 3. Expanding is the opposite of factoring. Expanding means removing the brackets signs, but we have to do it the right way. When removing brackets, the number outside the bracket, 2 in this case, is multiplied by all the numbers in the bracket. In this case, it is multiplied with y and then with 3. Now let's look at the example 3 multiplied by 5 plus y. Multiplying every number in the bracket by the number outside the bracket, we get 15 plus 3y.